Hey everyone, let's solve LG54 spiral matrix. So we are given a matrix and we have to return all the elements in a spiral order. We have to do a traversal in spiral order and store all the elements in a list and we have to return it. Okay, so I think we have understood the problem well. Next, let's try to break down the approaches, what and how we are going to solve this problem. Okay, if you carefully notice, what we are doing here is we are just traversing towards right and we are just noting down all the elements like 1, 2, 3, 4, and we are taking some decision at the element 4 and we are just changing the direction from left to right. We are going top to bottom, right? So 5, 6, 7, now we are going in a bottom direction, and at element 7 we are taking one more decision, like some decision is being applied on some condition. The decision we took is we are going to move towards right to left. Earlier it was top to bottom, now it is right to left, and we are continuing our traversal 8, 9, 10. Then at element 10 we are again changing the direction from right to left to bottom to top, right? Then we have 11 and 12. Then we are again doing the same operation. Whatever we have did on 1, 2, 3, 4, we are just repeating it, right? uh, let's try to take down some of the nodes. So we are taking some decision based on some condition, right? At one point of condition we are making some decision. So at what condition we are making the decision? When I reach the end of the matrix, like when I reach the boundary, right? So after 4 there are like no elements towards right, so this can be considered as a right boundary. And you can also see I have changed my direction when I reached element 7. Why did I change my direction? Because I reached a boundary like the bottom boundary. And on reaching 10 I again changed my, like I have made some decision of changing the direction. So why did I make a decision here? Because 10 is the left boundary. Since I have reached the left boundary, there are no elements left to 10. I have just changed my direction. So we can note it down like whenever we reach a boundary, we are just changing the direction. Next, if that is the case, when we are at element 12, we could have continued in the upward direction, but again we have changed the direction, right? So why did we change direction at element 12? Because we know 12 is not the boundary of this particular matrix, but we are changing the direction. So the other condition when we change the direction is because the element 1 that lies in the top of 12 is already visited. So since it is already visited, we are changing the direction, like from moving bottom to top, we started moving from right to left, right? So whenever we see already visited element, change the direction. Now lastly, when should we stop doing the traversal? We should stop doing the traversal whenever we reach all the elements of the matrix, right? So that is simple. Stop when you reach all elements. And is there any other points we have to note it down as the operation that we are doing here is just a cycle. We are just repeating. We are going left to right, top to bottom, right to left, bottom to top. Again, we are just repeating whatever things I have told, right? So the basic direction shift we are doing is left to right, then top to bottom, then right to left, then bottom to top. So again, we are just repeating these operations till we reach all the elements, right? So based on these notes, we can derive the solution. Got it. Now we have understood that we have to perform these operations, like we have to traverse from left to right, top to bottom, right to left, and bottom to top. That's what I have written here. So left to right means go right, top to bottom means go bottom, and right to left here I have denoted as go left, and bottom to top I have denoted as go top, and we just have to repeat till we reach all the elements. So when I should do the operation go bottom is there is some condition we have to, like, we made some decision at element 4, right? What kind of decision we have made is if we reached the boundary or if we see the element is already visited, we have to change the direction. So that is what we are going to do now. Let's say I'm starting with the element present at index 0 comma 0. I will just go right. Okay, now I am at element 2. I will check whether did I reach the boundary or is the 2 already visited. Both are false. So I will just do the traversal. I will just continue with my traversal. I will go to 3. I will check this condition. Again false. Then I will go to 4. Now I will check this condition. Now I have reached the boundary, right? Okay, what am I going to do is, since I have reached the boundary, from go right, I will choose the next operation, like next direction is go bottom. Okay, now I will just go in a bottom direction. 4 to 5 I will check whether 5 is the boundary, or if it is already visited both are false, then I will go to 6, and when I reach 7 I know the boundary is, we have reached the boundary, so I will start going towards left. Now it will just, we will traverse till element 10, and when we reach element 10 we know we have reached the boundary. So I will just go in the top direction. And when I am at 12, when I try to move towards 1, I know 1 is already visited. So I should just stop here, and we just have to repeat whatever we have been doing here. Again, go right. So at element, when I'm at element 12, I will again start going towards right. I will check whether it is already visited, 13 is not visited, and 13 is not a boundary. So I will just go towards right. 13 comes, then 14, and when I am at 14, I will check whether I have reached the boundary. No, I haven't reached the boundary, but the element 5 is already visited. So from go right, I will, okay, let me just differentiate. I was in go right. Now I will just choose go bottom. Now we are in go bottom stage. Now, since I'm in 14, I will just go towards element 15. I will check whether 15, the boundary is reached. No, boundary is not reached. But the element 8 is already visited. So it's time to change the direction. I will change the direction from go bottom to go left. So when I reach element 16, everything is done, right? I have reached the whatever element I choose here is already visited. And the other point to note is we have to stop when we reach all elements. So that is what we are going to do. Now, whatever things I have discussed here, let's just do the same in coding part. Okay, let's create a list to store the answer. Okay, and it's equal to new linked list. Now, let's do the traversal part here. So what will be the base condition here would be, we have to stop when we reach all the elements, right? How will we know it is? I will compare the size of the, if the size of the final list is equal to the matrix, the number of elements in a matrix, then we should stop it. So what I'm going to do is, let me store the number of rows and columns in m and n. Now it will be m into n. Here, what I'm going to do, as discussed, we will go right first. So what does go right here means? What will be our starting position? Our starting position will be matrix of 0 or 0, right? This is going to be our start position. Let me just add it here. I equal to 0 and j equal to 0. Now, since the first element is added to the list, I will mark this as a visited element. How will I mark this as a visited element is, I will assign with minus 101. Why 101? Because here you can see the element will range from -100 to +100. So no element will have a value of -101. So this will be an identifier where we can tell whether this particular position is visited or not. Okay. As discussed, what are the things we have to take care is if the boundary is not reached and if the element is not visited, we can push it to the answer list. That is what we have to do. So let me just write down the condition for it. How will I check whether the boundary is not reached? This j should be less than n, like j plus 1. Currently, I'm at this column, like j has 0. I have to wait. Okay. I have to move towards 4, move till 4, and after 4 I should stop. How will I know I have to stop at 4 is if the j value is going to exceed the boundary is n, if it is going to exceed the boundary I should stop. If we are within the boundary and if the element is not yet visited, we are good to add this element in the answer list. So what I'm checking is if the new position is within the boundary and if the new element is not yet visited, I will add it in the answer. Okay, before adding, I will update the value. Now j has updated position, so I will add matrix of I of j. And let's not forget to do this step. I am marking this as visited. Okay, let's just do the same process for 4 times. 4 times but different directions. From go right, I will do the go bottom. And go left, then go top as per the diagram. And to go bottom, the boundary would be, if I have to go bottom, I have to do I plus 1. And if I'm going to I plus 1, the boundary is m. And let's just update it here to I plus 1, I plus equal to 1. Okay. If I have to go left, I will do j minus 1 because we are going towards left direction, right? Opposite of this right direction, that is j minus 1. And here the left boundary is always 0. Let's just do that. Next, if I have to go top, I will do I minus 1. And the top boundary is again 0. Okay, did we do everything right? Left, top, bottom, right. Got it. Let's just return the answer.